Hi students, in this module you will study about electrical resistance. Learning objectives. State that resistance equals potential difference divided by current and understand qualitatively how changes in potential difference or resistance affect current. Recall and use the equation R equals V divided by I. Describe an experiment to determine resistance using a voltmeter and an ammeter. Relate the resistance of a wire to its length and to its diameter. Sketch and explain the current voltage characteristics of an ohmic resistor and a filament lamp. Recall and use quantitatively the proportionality between resistance and length and the inverse proportionality between resistance and cross-sectional area of a wire. Resistors in series and parallel. Electricity is the flow of electrons. The amount of charge or the number of electrons flowing through a conductor in unit time is called electric current. If the electromotive force or EMF of a cell is high, it can provide more energy to the electrons to flow through the conductor. When electrons flow through a conductor, it will interact with the atoms or molecules of the conductor. This interaction or collision affect the free movement of electrons, or we can say there is resistance. Electrons move more easily through some conductors than others when a potential difference is applied. The opposition of a conductor to current is called its resistance. A good conductor has a low resistance and a poor conductor has a high resistance. The resistance of a wire of a certain material increases as its length increases. Resistance increases as its cross-sectional area decreases. It also depends on the material. A long, thin wire has more resistance than a short, thick one of the same material. The most conductive elements of the periodic table are metals. Silver has the highest electrical conductivity, that is lowest resistance. Then copper, gold, aluminium, etc. Copper wires are used in electrical circuits at home. Aluminium wires are used for transmission of electricity over long distance. The unit of resistance is ohm. If the current in a conductor is I, when the voltage across it is V, its resistance R is defined by R equals V divided by I. Also we can write V equal to IR or I equals V divided by R. The ohm is the resistance of a conductor in which the current is 1 ampere when a voltage of 1 volt is applied across it. You can see different types of resistors here. The upper picture is the circuit symbol of resistor. Usually carbon resistors are used in electronic and electrical circuits. There will be some color codes. By looking at that color code, we can find the value of resistance. Usually variable resistors are used as volume controllers and other controllers in radio and TV. Here you can see one variable resistor with the 3 terminals, terminal 1, 2 and 3. Between the terminal 1 and 3, a resistive material is coated. The wiper is connected to terminal 2. By rotating the wiper, we can change the resistance between the terminal 1 and 2. If we connect between the terminal 1 and 3, then we will get fixed resistor. Large variable resistors or rheostat is used in science lab. You can see a rheostat with 3 terminals, left side 1 terminal and right side 2 terminals. The upper terminal is connected to a good conductor. Between the left terminal and right side bottom terminal, you can see a coil of constant wire, a resistive material. It is not insulated. Now, if you connect one wire to the left terminal and another wire to the upper right terminal, you can change the resistance by moving the sliding contact. If the position of the sliding contact is near the left terminal, at the top of the left terminal, then current will pass through that good conductor where the sliding contact is connected. So there will be no resistance. But if the position of the sliding contact is near to the right terminal, then current entering to the left terminal needs to pass through the resistance wire for some distance, then reach the sliding contact. So by moving the sliding contact, we can change the resistance. This rheostat can be used as a potential divider. Ohm's law is a relation connecting voltage, current, and resistance in a circuit. Ohm's law states that at constant temperature, the current flowing through a metallic conductor is directly proportional to the potential difference applied across the terminals of the conductor. You can see the experimental setup to study Ohm's law. Here is a battery. You can see the positive and negative terminal of the battery. Ammeter is connected in series with the circuit. So the positive terminal of the ammeter is connected to positive terminal of battery. Here R is the resistance. A voltmeter is connected parallel to the resistor. Here also you can see the polarity of the voltmeter. The negative terminal of the voltmeter is connected to negative terminal of battery. Electricity will flow from positive terminal to negative terminal of battery. You can measure the value of voltage between the terminals of the resistor and the current flowing through the circuit. Now you can repeat this practical by connecting a variable resistor in series with the battery. So when we change the resistance of the variable resistor, there will be change in the value of current in the ammeter and the potential difference between the terminals of the resistor. But if you take the ratio of voltage and current, V divided by I, we get a constant called the resistance of the given resistor. We can plot a graph by taking voltage along the x-axis and current along the y-axis. Voltage is the independent quantity and current is the dependent quantity. At constant temperature, we get a straight line graph. We can construct a triangle and you can find out I divided by V, or a change in current divided by change in voltage. So the reciprocal of delta I divided by delta V, or the reciprocal of the slope gives the resistance of the given resistor R. Resistance of metallic conductor. If outermost electrons are detached from the atom, then the atom will become a metal ion, and the electrons existing as a sea of free electrons. When we apply a potential difference between the two terminals of the conductor, electrons repel from the negative terminal and move towards the positive terminal. During this motion, electrons collide with the metal ions or the metal atoms. Increase in temperature causes increase in vibration of atoms. Vibration of atoms reduce the free movement of electrons. So the resistance of metallic conductor increases with temperature. Resistance of semiconductor, silicon semiconductor. A semiconductor in its pure form at very low temperature is a resistor, or it's not a good conductor. You can see a silicon crystal. Usually silicon and germanium are used as semiconductors in electronic circuit. Here in this silicon, there are 4 electrons in the outermost orbit. These 4 electrons make covalent bond with a neighboring silicon. So covalent bond is formed by sharing electrons with the neighboring atoms. So therefore, there is no free electrons. So at low temperature, it cannot conduct electricity. But if there is some impurity, it can contribute to conductivity. Or if you increase the temperature, some of the covalent bonds break and electrons will come out from that bond. So these free electrons contribute to the conductivity of silicon or germanium crystal. Therefore, an increase in temperature causes breaking of covalent bonds between silicon atoms and increase the number of free electrons. The resistance of a semiconductor decreases with increase in temperature. IV characteristics or current voltage characteristics. Here you can see the graph of current voltage relation for metallic conductor and semiconductor. Ohmic conductor is a metallic conductor. Diode and thermistors, they are electronic devices made up of semiconductors, and filament lamp is made up of tungsten metal. So here in the first picture, at low temperature, the current is directly proportional to voltage. So we will get a straight line graph. Now for the filament lamp, at low temperature, the resistance is not varying. So current is proportional to voltage. But after some times, due to temperature, the resistance will increase. So current is not proportional to voltage. So you can see it is slightly curved downward. Now for semiconductor diode and thermistor, it is not following Ohm's law. When temperature increases, the current is increasing. So at low temperature, current increases with voltage, but after some time, due to high potential and due to temperature, there will be production of electrons from the covalent bonds, and this will increase the conductance of semiconductor, or the resistance of semiconductor will decrease. In electrical circuits and electronic circuits, we have to use different resistors at different junctions. We can achieve a high resistance by connecting resistors in series. Here you can see 3 resistors R1, R2 and R3 connected in series to a cell. Capital I represents the total current in the circuit. Same number of electrons pass through R1, R2 and R3. In series connection, the same current I flows through each resistor, and the total voltage V across all 3 is the sum of the separate voltages across them. That is, capital V equals V1 plus V2 plus V3. V1 is the potential difference between the terminals of R1, V2 is for R2, and V3 is the potential difference between the terminal of R3. Or we can say V1, V2, V3 represents the potential drop across R1, R2 and R3. But based on Ohm's law, we know V1 equals IR1, V2 equals IR2 and V3 equals IR3. Now let capital R represents the effective resistance of these three resistors in series. I is the common current. Then capital V equals IR. That is IR equals IR1 plus IR2 plus IR3. We can take the common factor I and we can remove I from left hand side and right hand side, or we can divide throughout by I. Then we get capital R equals R1 plus R2 plus R3. Now if we have two resistors in series, then effective resistance is R1 plus R2. If we use more than three resistors, we can write effective resistance equals R1 plus R2 plus R3 plus R4 plus etc. The combined resistance of several resistors in series is larger than the resistance value of the largest resistance in the circuit. For example, if we have three resistors, say 1 ohm for R1, 5 ohm for R2 and 100 ohm for R3, then effective resistance is more than 100 ohm. Resistors in parallel. Sometimes we have to achieve very low resistance. To get very low resistance, we connect resistors in parallel. Here you can see three resistors R1, R2 and R3 connected in parallel to a cell. The main current in the circuit is I, but this current will split across this resistor. So I1 is the current flowing through R1, I2 is the current flowing through R2 and I3 is the current flowing through R3. Based on the difference in resistance value, there will be change in the current. So some number of electrons pass through R1 and there may be some electrons passing through R2 and some through R3. The number of electrons passing through each resistor, it depends upon the value of the resistance. Low resistance means more electrons will pass through that resistor. In parallel connection, the voltage V between the ends of each is the same and the total current I equals the sum of the currents in the separate branches. So we can write capital I equals I1 plus I2 plus I3. But based on Ohm's law, we can write I1 equals V divided by R1, I2 equals V divided by R2 and I3 equals V divided by R3. Now suppose R represents the effective resistance of this combination. We can write capital I equals V divided by R. That is V divided by capital R equals V divided by R1 plus V divided by R2 plus V divided by R3. We can divide both sides by V. We will get 1 by R equals 1 by R1 plus 1 by R2 plus 1 by R3. Here you have to be very careful. R is the effective resistance of parallel combination. But reciprocal of effective resistance is 1 by R1 plus 1 by R2 plus 1 by R3. So to find out the combined resistance of three resistors in parallel, first we have to find out 1 by R1 plus 1 by R2 plus 1 by R3. Then you have to take the reciprocal. Then we will get the effective resistance. The combined resistance of resistors in parallel is less than the resistance of lowest resistance in the circuit. That means if we have 1 ohm resistance, 5 ohm resistance and 100 ohm resistance in parallel, then the value of effective resistance is always less than 1 ohm. Color code of resistors. Usually carbon resistors are used in electronic and electrical circuits. They are very small components, so it is difficult to label the resistance. So to solve this problem, we use color codes. You can see a number of colors around the carbon resistor. Usually these colors we can see on one side of the carbon resistor. So you have to start from that side. Usually there will be four colors. Here you can see black, brown, red, orange, yellow, green, blue, violet, grey and white colors represents the digits 0, 1, 2, 3 up to 9. In carbon resistor, first color represents the first digit. Second color represents the second digit. Third color represents the power of 10 or the number of zeros that we have to put. The fourth color represents the tolerance. By looking at tolerance, we can say how much variation for the resistor. We know that the resistance of a carbon resistor changes with temperature. So the tolerance represents that variation. If the fourth color is gold, plus or minus 5% tolerance. That means if the value of resistance is 100 ohm, then it can vary from 95 ohm or up to 105 ohm. Now, if the fourth color is silver, then tolerance is 10%. So the resistance can vary from 90 ohm to 110. Similarly, if there is no band, then it is 20%. So if there is no fourth band, only 3 bar or 3 colors, then the tolerance is very high, 20%, plus or minus 20%. So here you can see some examples. Right hand side you can see yellow, violet, orange and silver. So what will be the value of this resistance? Yellow means 4, violet it's 7, and after that we have to put how many zeros? 3 zeros. Then silver represents the tolerance, that is plus or minus 10%. For the second resistor it is brown, black, red. So 1, 0, then 10 to the power 2. Now you can see another carbon resistor, brown, red, brown, and the last color is golden color. So first digit is 1, the second is red, so 2, and again brown. So the brown represents the number of zeros coming. Now it is golden color, so the tolerance is plus or minus 5%. Resistivity. Resistance R of a wire of a given material is directly proportional to its length L. That is, R is proportional to L. Then it is inversely proportional to its cross-sectional area A. Or we can say R is proportional to 1 over A. Combining these two statements, we get R is proportional to L divided by A, or R is equal to a constant rho into L divided by A, where rho is a constant called the resistivity of the material. In this equation, if we put L equal to 1 meter and A equal to 1 meter square, then rho equals R, or we can say the resistivity of a material is numerically equal to the resistance of a 1 meter length of the material with a cross-sectional area 1 meter square. The unit of resistivity, rho, is ohm meter. Now one thing you have to remember is resistance is the property of the given wire. For example, we can give an iron or a copper wire having length 1 meter or 2 meter or 3 meter. Then we will get different resistance for these wires because resistance depends upon length. Also, resistance depends upon area of cross section. More area of cross section means less resistance. But resistivity is the property of the material of the wire because it is already defined as the resistance of unit length and unit area of cross section. Potential dividers in electrical circuit. You can see a potential divider circuit. Two resistors R1 and R2 connected in series to a cell of EMF V. I represents the total current. The potential drop across the resistor R1 is V1 and potential drop across the resistor R2 is V2. Now here the total current I is equal to supply voltage divided by total resistance. Supply voltage is V and the resistors R1 and R2 connected in series, so the effective resistance is R1 plus R2. So therefore effective current I is equal to V divided by R1 plus R2. Now V1 equals I into R1, that is V divided by R1 plus R2 times R1. So we can rearrange it as V times R1 divided by R1 plus R2. Similarly, V2 equals V times R2 divided by R1 plus R2. Here V1 represents the potential drop across R1 which depends upon R1, and V2 is the potential drop across R2 and it is directly proportional to R2. Here the term V divided by R1 plus R2 is a common term in both the equations. So by comparing these equations we can say V1 is proportional to R1 and V2 is proportional to R2. So in different types of electrical circuits we can vary this resistor, say R1, or we can vary the R2 or replace with some variable resistors like light dependent resistor or some other components. So by varying this resistance we can vary the potential drop. Let us study some circuits containing resistors in series and parallel. Here let us calculate the effective resistance between A and B in this figure. Here you can see two resistors R1 and R2. The first resistor is 4 ohm, second also 4 ohm. You can use similar resistors or different resistors. Now for a parallel connection we know reciprocal of effective resistance 1 by R equals 1 by R1 plus 1 by R2. That is 1 by R equals R2 plus R1 divided by R1 times R2. That is, if you take the reciprocal of effective resistance, we will get this equation. So therefore, effective resistance R equals R1 R2 divided by R1 plus R2. That is, R is equal to 16 divided by 8. You will get effective resistance 2 ohm. We can find out this value in another way, just by using the equation 1 by R is equal to 1 by R1 plus 1 by R2. That is, 1 by R equals 2 divided by 4. Therefore, R is equal to reciprocal 4 divided by 2. We will get effective resistance R is equal to 2 ohm. So it's a parallel connection. So the value of the effective resistance is lower than the individual resistors. Here you can see two circuits. The first circuit is series connection and the second one is parallel connection. So what is the effective resistance in figure between A and B and also between C and D? The first one is very simple. It is a connection of resistors in series. So effective resistance R is equal to R1 plus R2 plus R3. You will get 15 ohm. Now for the second resistor, 1 by R equals 1 by R1 plus 1 by R2 plus 1 by R3. That is 1 by R is equal to 1 by 6 plus 1 by 6 plus 1 by 3. That is 2 by 6 plus 1 by 3 equal to 1 divided by 3 plus 1 divided by 3. You will get 1 by R equal 2 over 3. Now we have to take the reciprocal. So R is equal to 3 divided by 2 equal to 1.5 ohm. Now if you look at these answers, we can see in series connection we can see 3 ohm, 6 ohm and 6 ohm, and the effective resistance is more than 6 ohm. Now for the parallel connection, 3 ohm is the lowest resistor, but when we calculate the effective resistance the effective resistance is coming less than 3 ohm, that is 1.5 ohm. Here you can see combination of series and parallel connection. The potential difference of 24 volt from a battery is applied to the network of resistors. So here you can see an 8 ohm resistor, then 6 ohm resistor and 12 ohm resistor. 6 ohm and 12 ohm resistors are in parallel and 8 ohm resistor is in series with that parallel combination. So first of all, so what is the combined resistance of 6 ohm and 12 ohm resistors in parallel? Now here let us say R1 is the effective resistance of this parallel combination 6 ohm and 12 ohm. Then 1 by R is equal to 1 by 6 plus 1 by 12. That is 2 by 12 plus 1 by 12 equal to 3 by 12. Now we have to find out the reciprocal. So therefore R1 is equal to 12 divided by 3 equals 4 ohm. So we get the effective resistance of that two parallel resistors equals 4 ohm. Now what is the current in the 8 ohm resistor? Let R be the total resistance of the circuit. That means the sum of the two parallel resistors and the resistance of 8 ohm. So that is 4 plus 8 equal to 12. So 12 ohm is the total resistance in the circuit and 24 volt is the voltage in the circuit. So therefore I is equal to V divided by R, that is 24 volt divided by 12 ohm, you will get 2 ampere. So 2 ampere is the effective current in the circuit. Now the third question, what is the voltage across the parallel network? We know when we connect resistors in parallel, then we will get a common voltage. So let V1 is the voltage across the parallel network. So we can write V1 is equal to I into R1, that is 2 ampere times 4 ohm. So you will get 8 volt. Now what is the current in the 6 ohm resistor? Here let I1 is the current in 6 ohm resistor. Then since V1 is equal to 8 volt, we can write I1 is equal to V1 divided by 6 ohm. So 8 volt divided by 6 ohm, you will get 4 divided by 3 ampere. If you like this video, you can subscribe and share. If you have some questions or suggestions, you can type in the chat section. Thank you.